Hello everyone, we are going to consider this exercise where we have 3 steps in a thermodynamic cycle. The first step is an adiabatic step, then we have an isochoric, and then an isothermal. So in the first question we want to draw the Clapeyron diagram, but before doing that we are going to specify for every single step the information that we have from the wording and the easy information that we can deduce from that. So let's do that. So question 1. The first step is from state 0 to state 1. And here we have a compression that is adiabatic. So the information that we can write, first of all, from the wording is the fact that V1 is equal to V0 over 3. So this is given in the wording. And then because it's a compression, we can deduce the fact that P1 is higher than P0 and the fact that T1 is higher than T0. Because when you compress something, then the pressure and the temperature are going to increase. Then the next step is 1, 2, 2. And this is an isochoric cooling. Now the information that we've got here is the fact that, first of all, isochoric means the volume is constant. So we have V1 that is equal to V2. And we specified earlier that V1 is equal to V0 over 3. So V2 is also equal to that. The another information that is given in the wording again is the fact that T2 is equal to T0. And we can deduce the fact that P2 is smaller than P1 just because it's a cooling, then we can deduce that. The last equation is from state 2 to state 0, as it's a cycle. For a cycle, the final state is always the same than the initial state. That's why we come back to 0. And here it's an isothermal transformation. Isothermal means temperature constant, so necessarily T2 is equal to T0. And something that is interesting, it's not requested yet in the exercise, but it's typically something that you can deduce by yourself easily when you have such information. So here we don't have any information about the pressure P2, but we can deduce it by using the perfect gas law, because perfect gas law says that PV equal to nRT. So that being said, we are going to apply this to the two steps, the step 0 and the step 1. Sorry, the step 0 and the step 2, I mean. So for 0, it's going to be P0, V0 equal to nRT0. And for the step 2, it is P2, V2 equal to nRT2. So that being said, we can then use this one, and we are going to express T0 from here. Okay, so this is done. And then in the same time, we know that T2 is equal to T0, so this is also equal to T2. So once I know that, I'm going to come back to the second equation, and I'm going to take this expression of T2 and replace it inside. So I'm going to take that expression here. So now I will have P2 times V2. But there is something that I know about V2 actually, because I just expressed V2 here. So it's going to be V0 over 3. And then for the NR, I'm going to keep it. And for T2, I'm going to use the expression that I just expressed at the moment. So it's going to be P0 V0 over NR. I can simplify NR here and here. I can simplify the V0. And everything now that I have that is left is just the 3 and the P0. So finally, I can tell that P2 is equal to 3P0. So just by using the perfect gas law, I was able to deduce P2, even if it was not given in the wording. And that is going to be useful for the next steps in the exercise. So now we can go to the next page.